When we talk about internet speed, most people think of numbers like 50 Mbps, 1 Gbps, or even future technologies promising terabit connections. But behind all these impressive figures lies a very simple concept, the movement of tiny digital units called bits. Every image you load, every message you send, every video you stream, and even every click you make on a website is made possible because millions or billions of bits travel from one point to another every second. To understand how far internet technology has come and where it's heading in the future, we first need to understand the scale of these measurements. At the very bottom of the hierarchy is bits per second, or Bps. It represents the number of individual bits, just zeros and ones, that a connection can send or receive each second. It's the foundation, the starting point, the basis of all digital communication. Imagine a world where your connection only transfers a single bit every second. 1 bit. At that speed, sending just one character, like the letter A, which requires 8 bits, would take 8 long seconds. It's painfully slow by today's standards, but this simple unit is the cornerstone on which the entire digital world was built. From this tiny starting point, we scaled upward, first to kilobits, then megabits, then gigabits, each level pushing the limits of what communication technology can achieve. Each jump didn't just make the internet faster, it completely transformed what people could do online. Early mobile networks allowed basic text browsing. Later, high-speed broadband unlocked streaming, gaming, cloud computing, and real-time global communication. And now, experimental technologies are reaching speeds so fast that they challenge our imagination. In this video, we're going to explore that journey. We'll break down every major speed unit, from Bps all the way up to theoretical future speeds like yottabits per second, and we'll look at what these levels actually mean in real-world terms. How fast is fast? How much data can truly be transferred at these extreme rates? And what does the future of ultra-fast communication look like? By the end, you'll not only understand internet speeds better, but you'll also have a sense of how far we've come and how far technology might push us in the next decades. So, let's begin at the very bottom of the scale, where everything starts, the world of bits per second. Now that we've established the foundation, the simple idea of bits moving every second, let's climb the ladder of speed units and see how each major step reshaped the digital world. Every level we're about to explore didn't just represent a faster number, it unlocked new possibilities for communication, entertainment, and global connectivity. We start with kilobits per second, or kbps. A kilobit is 1,000 bits, and while that sounds small today, it was once considered groundbreaking. Early mobile networks, 1G and later 2G, operated in this range. Back then, loading even a basic web page felt like watching paint dry, but it was revolutionary. For the first time, phones weren't just for calling or texting. They could slowly display tiny images, simple websites, and basic online content. Technologies like Edge, reaching around 384 kbps, gave us our very first taste of mobile internet life. Emails, small downloads, and early messaging apps all lived comfortably in this era, but then came a major leap: megabits per second, or Mbps. A megabit equals 1 million bits per second. When 3G launched, it wasn't just an upgrade, it was a transformation. Suddenly, the internet became richer. You could browse social media, stream low-resolution videos, and download apps without waiting ages. As 4G and LTE arrived, Mbps speeds climbed even higher, tens, sometimes hundreds of Mbps, making high-definition streaming, mobile gaming, and real-time GPS navigation not just possible, but normal. However, many people misunderstood one crucial detail. Internet companies advertise speeds in megabits, while devices display download speeds in megabytes. Because 8 bits equal 1 byte, a 100 Mbps plan won't download at 100 megabytes per second. it will max out around 12.5 Mbps. So when someone sees their download moving at 10 or 12 megabytes per second, it's not slower than promised, it's simply using a different unit. Understanding this single conversion makes internet speeds far less confusing. From there, we move into the world of gigabits per second, or Gbps, 1 billion bits per second. This is where fiber optics, next-generation 5G, and large-scale data systems come alive. At gigabit speeds, the internet stops feeling like a tool and becomes something closer to an instant connection to the world. Downloading an HD movie takes seconds. Large game updates happen almost immediately. Cloud services, remote work, and online collaboration feel seamless. For power users, creators, and professionals, gigabit-level performance isn't a luxury, it's a necessity. But gigabits are only the beginning of high-performance networking. The infrastructure that powers entire countries, global companies, and massive digital platforms operates much higher at the level of terabits per second, or Tbps. 1 terabit equals 1 trillion bits per second. This is the speed essential for the internet's backbone, the undersea cables, data centers, and intercontinental networks that keep the entire online world running smoothly. A single terabit connection can move about 125 gigabytes of data every second. To put that into perspective, a system running at this speed could transfer your entire photo library in an instant. Companies like Netflix, Google, and Meta depend on multi-terabit pipelines to deliver millions of video streams simultaneously without crashing. Beyond that lies petabits per second, or Pbps, where technology begins to stretch into the limits of modern engineering. 1 petabit is 1 quadrillion bits. At this rate, an entire streaming service library could be copied in a single second. These speeds are not found in consumer networks. They exist in cutting-edge research labs studying the next generation of optical fiber and photon-based communication. In recent years, scientists have demonstrated petabit-level transfers, proving that the future internet will be thousands of times faster than anything we use today. Then we enter the realm of exabits per second, or Ybps, which is so massive that today's internet feels microscopic in comparison. At this scale, the limiting factor is no longer speed, it's the physical laws of light, energy, and information. Exabit-level communication could allow instantaneous synchronization between entire data centers, or serve as the backbone of global artificial intelligence systems. No infrastructure on Earth currently reaches this tier, but it represents the next horizon for ultra-high-speed communication. Climbing further, we reach zettabits, Zbps, and yottabits, Ybps per second, where the numbers stop sounding real and start sounding like science fiction. 1 zettabit per second equals the ability to copy all the data humanity has ever created within a single moment. A yottabit per second goes beyond even that, fast enough to download the entire internet in less than a second. Today, these speeds exist only in theories and future-focused research. They might one day power interplanetary networks, quantum communication systems, or global-scale AI that relies on instant data transfer. From kilobits to yottabits, each jump in speed marked a turning point in digital history. These advancements didn't just improve loading times, they reshaped how we work, learn, communicate, and entertain ourselves. And as we push toward the frontiers of petabit, exabit, and beyond, we're stepping into a future where data moves so fast that the limits of distance, storage, and even time begin to fade. As we reach the end of this journey through the world of data speeds, one thing becomes very clear. The evolution of internet connectivity is not just a story of faster numbers. It's the story of how human communication has transformed at every level. From the earliest days of slow kilobit networks to today's gigabit fiber and experimental petabit research, every step has shaped the way we live, work, and connect with the world. What began with a single bit traveling each second has grown into a global system capable of moving billions, trillions, and even quadrillions of bits in the blink of an eye. These speed units, BPs, kbps, MBPs, GBPs, Tbps, and beyond, aren't just technical terms. They represent milestones in human progress. Each leap opened a new chapter in digital life. When we reached kilobits, we saw the first web pages load on mobile phones. With megabits, streaming, social media, and mobile apps became everyday realities. Gigabits brought seamless cloud computing, instant downloads, and a world without buffering. Terabits created the backbone of the modern internet, the invisible highways that carry global traffic. Petabits and exabits push us toward a future where distance might no longer matter, where data moves almost as fast as thought. And the theoretical realms of zettabit and yottabit technology remind us just how far innovation could go in the next century. What's truly astonishing is that this growth is not slowing down. In fact, it's accelerating. Researchers are already experimenting with light-based data transfer, satellite lasers, next-generation fiber, and quantum communication. These technologies may one day make it possible to sync entire data centers across continents instantly, power global-scale AI systems, or even connect Earth to Mars with minimal delay. If the past decades taught us anything, it's that the speeds we consider impossible today will become normal tomorrow. Just as early users of 2G could never imagine streaming 4K video on a phone, we too cannot fully imagine the digital experiences that exabit or yottabit networks will unlock. But one thing is certain: the future of communication will be built on the same foundation it started with, a single bit. Billions and trillions of them traveling through invisible networks, shaping our digital world one moment at a time. Understanding how these units work doesn't just help us read an internet bill or compare network speeds. It reminds us of how far we've come and how far we still have to go. From the slow, patient loading bars of the past to the instant, high-bandwidth reality of today, the story of internet speed is ultimately the story of human ambition, our constant push to connect faster, share more, and reach further. And as we continue upward through the scale of bits towards speeds once thought unimaginable, the next generation of technology will redefine what it means to communicate, to explore, and to be connected in a world where information moves at the speed of possibility.